Here we have a simple exercise and we are asked to calculate the voltage measured by this voltmeter. So we can use first calculate the equivalent resistance of this circuit and then calculate this current and then calculate the drop in this resistors. Well, we can use as well a voltage divider. We have here 3 resistors and these that are in series, so it means that if we call it VR2 3, 4, it means the voltage across these resistors. Then we can say that using a voltage divider, VR 2, 3, 4, voltage across these 3 resistors is equal to the equivalent resistance of these 3 resistors over R2, 3, 4 plus R1 plus the internal resistance of this source times the voltage at this source. That's it. So let's calculate first R2, 3, 4. R2, 3, 4 it's R2 in parallel with R3 plus R4, which are in series. So R2 is 30 in parallel with 5 plus 10, which is 15, and this will give us 10 ohms. Now let's calculate the denominator, which is the equivalent resistance of this circuit. It's R2, 3, 4 plus R1 plus R. It means it's 10 plus 18 plus 2, it's 30. And from this we can calculate this voltage, which is 10 over 30 times this voltage, which is 12. So it means 1/3. It means it's 4 volts. It's done. The second one is this exercise, and here we have to calculate the charge at this capacitor. To calculate the charge stored in the capacitor, we have to calculate the voltage across the capacitor. And the voltage across the capacitor, once it's charged, it means that the voltage across this capacitor will be the voltage across the R2, because here, after the capacitor is charged, no current is flowing, there is no drop at this resistor, so it means all the drop is on the capacitor. So it means we have to calculate VR2. Once we have VR2, we can calculate the charge, which is VR2 times C, capacity of the capacitor. It means remembering that VR2 is equal to VC. To calculate VR2, we have to calculate the current flowing in this circuit, and this current I is V over R1 plus R plus R2, and this is 6 over 2 plus 1 plus 3, so it means it's 1 amp. And from here we can calculate VR2. VR2 it's R2 times I, and this is 3 times 1, this is 3 volts. And from here we can calculate the charge at the capacitor. It's VR2 times C, it's 3 times 2 microfarads. Here we have 3 volts. Volts times farads is coulomb, so it means it's 6 microcoulomb. And that's it. We finish, and thank you very much.